Okay, so here's our first resultant force problem. This is a classic. Two forces are being enacted upon an object at rest. One of the forces is pulling up with a force of 40 pounds at an angle of 45 degrees. So stop there. The force is labeled in terms of pounds. There's a previous video where we talked about how the force labeled as pounds, that's the magnitude of that first force, okay? Pulling at an angle of 45 degrees. That's measured from the positive x-axis, okay? So as we go through this, no, I don't want that. Okay, as we go through this, oh, there we go. Here's what I'm going to do. Because these forces are being measured from the positive x-axis, I'm going to include as my drawing just this horizontal plane. Here's the object that is at rest. Okay, it could be anything. So this object which is sitting here, when I talk about these forces pulling in a specific direction, because I have to measure from the positive x-axis, I want a horizontal plane like this, or a horizontal line that I can measure those from. So I've got a smart board to make this a little bit easier and make things straighter. One force is pulling with a force of, I get that, with a force of 40 pounds at an angle of 45 degrees. So from this object, we have a force, right? This vector, the longer I make it, the stronger the force, and the angle that I use has to match what they're saying here. So this would be 90 degrees, because remember, our forces are always measured from the positive x-axis, right? So this is 90, 45 degrees, you guys know, is halfway through. So I might not be exactly perfect. And I have no frame of reference right now for what 40 pounds looks like, but I'm just going to put that right here, and then I'm going to label it. This magnitude is 40, and this angle is 45 degrees, okay? A second force is pulling with a force of 60 pounds at an angle of 135 degrees. So this second force is stronger than this, and it's pulling at an angle of 135. So if I measure from the positive x-axis, that's 90. Over here would be 135. You should know that from your work with the unit circle, I hope. Now when I draw this force vector, I need to make sure I make it longer than this one. Because again, the length of the vector represents how strong the force is. So and I get that that's kind of a new concept for you, so, but that's why we're practicing this. So since I decided this was what a 40-pound force would look like, this is what a 60-pound force looks like, okay? And we know that the measure of this angle is from here all the way over to here. We know that's I didn't do poorly. 135, and it's 60 pounds. Okay. Find the resultant force vector of the movement of the object. Now here's what I'm going to do. Okay. Did I get them all? Let's see. Ooh. I'm going to bring this whole thing down here for a second, because I want to re-emphasize the idea that we can represent the dynamics of this movement or this force without doing any math to get an idea of what's going to happen, okay? So the resultant force is the result of these two forces being moved on this object. Now, consider this. If you had a force, let's say pulling in this, it is pulling, sorry. If the force was pulling in this direction and in that direction, and they're both pulling up, right? Where's this object going to go? Clearly it's going to go up. And since this vector is a little bit longer than this vector, not only is it going to go up, it's probably also going to end up going to the left a little bit more because this force is stronger, right? We can get an idea, our picture's not perfect, but we can get an idea of where this object's headed if we physically, graphically, add that force to that force, right? We talked about that. How if you copy this and connect the initial point of this vector, right? Copy this take the initial point, move it to the terminal point. This object, well, let's use a line. This object is going to be headed from here in that direction with that amount of force. Now, again, the shortest vector drawn has the weakest force. This is stronger than that, but this is longer than both of those. Why? Because the force is so strong moving in this direction because both of these are pulling up. That's why it's represented with the longest vector in this case. Okay, so now our job is to numerically, right, calculate the actual direction and the force of this object moving in that direction. Okay, that's going to be in the second video. I didn't want this thing to go too long.